A big round of applause for Patrick on the best way to handle network calls, coroutines versus RX.
Good evening, everyone. I'm Patrick, a software engineer focused on Android development. Oh, that's all right. I'll spend around 10 to 15 minutes to talk about coroutines and reactive X. The network call is a good example we can use for comparison. Let's think about the difference between network calls and other general calls. Yes, we all know network call must be an asynchronous call. That means the important thing is how to handle the asynchronous call. So normally we use callback function to handle asynchronous calls. I think that is the most common way, but I reckon if you have experience with it, you will be familiar with the codes like this. This is a common use case. It fetches token, then fetches user data. After that, it still have to deserialize the response. So when you have a callback here, callback, the code tends to be less readable and a bit messy. If you got a callback in a callback in a callback like this, or even a callback in a callback in a callback in a callback, you get the point. It gets messy. This case is a messy. Let's see another case. I hope this one is worth enough. So normally this calls happens on the background thread, and if there are 10 network, 10 parallel calls, then you need 10 background threads. If those are sequential calls, then you only need one background thread. But the code will look like this. Okay, let's talk about bits of thread. You must have noticed the thread is not cheap. What does that mean? Each thread will cost at least 1 megabyte memory, and thread scheduling and switching is very expensive. It will cost high CPU usage. And also, we can't create unlimited threads because it won't be allowed by your memory and system. So by the way, generally the macOS only allow each process allocates around 2,000 threads. So creating 100K threads is impossible. If you insist on it, you will get this. I just use the Windows one because it's hard to find out macOS version or Android version. Now we need to find out we can do the same thing with better code readability and easier thread management. Reactive X. In Android world we use RX Java, and in iOS side we use RX Swift. Let's look into a code snippet. So you can see from this example, so RX makes the code to a chain. Now it's just a one level without any nested structures. At the same time, it puts fetch token, fetch user, and deserialize user into IO scheduler, and puts show user data on the main US thread. I think it fixed the code readability issue, but the thread issue is still there. So why it's just a half fix? Because the scheduler is also based on operating system thread. So this is some basic Rx schedulers. Let's walk through the schedulers. The first one is a computation scheduler. This is based on fixed thread pool, Java thread pool. And the second one is I/O scheduler. That is a shared growing thread pool. That means once it gets a bunch of work, it will create a new thread for you automatically. So the last one, trampoline scheduler. It is normally we use that just for the unit tests to override the other tools because it will make your call to synchronize the call. I think it's better than we manage the individual threads or thread pool manually, but it's thread essentially. So Kotlin Coroutine is another option. Here's a code snippet using coroutines. So the launch function launches new coroutine on UI thread. Actually here is a UI dispatcher, but it is based on the Android UI thread. And then it calls functions in a suspending block. So this lambda statement is just like a wrapper for your network calls. So if you, and also you can put those lines, where's the mouse? Sorry. And also you can put those lines into a separate suspending function. Then you don't have to use this with context. Then it suspends the function until it completes. After that, it updates UI on the UI dispatcher. So the order of the execution is show loading spinner first, and then print the text. After that, call network one by one. Finally, updates the UI on UI thread. So here, so it looks better than callback. And if you are familiar with Rx, I think this is a good way because you don't have to change your programming mind to reactive programming way. You might worry about the test. I would say don't worry about that. You can just simply pass unconfined dispatcher to replace the default dispatcher. That should work. And here are some Kotlin built-in dispatchers. If you don't define a dispatcher, it will use a default dispatcher. It is based on a fixed size thread pool. And also you can convert your own thread pool or executor into Kotlin Coroutines dispatcher. Keep this point in mind. Let's talk about performance. Here is performance test results. It uses iterations as a test case. We create tasks one by one and execute after it's created immediately. So there are many thread switches. For 10K iterations, Java and Coroutine consume the similar memory usage. Coroutine needs less CPU results and faster. But for 1,000 iterations, they consume similar results and got similar execution time. So I would say it's not quite different when you build your mobile app. Here's an example. Where's the screen? Sorry. Cool. Oh, it's very small. Give me a second. Anyway, it's it got two functions. One using a coroutine to make the network call. The other one use RX. So it's trying to fetch the next rocket launch detail from SpaceX API. So let's see the coroutine one. Oh, sorry, there's no internet on my laptop.
You can use the guest Wi-Fi signal.
Yeah, let me contact Google Guest. Do I have to log in?
No.
No. Oh, awesome. Cool. Oh, here's the cost per launch. I'm not sure if that is a real price, but it is from SpaceX API. So for this app, I use retrofit with coroutine adapter. So that adapter is similar to retrofit RxJava adapter. So it can wrap the retrofit object into a coroutine deferred object. That means there's no the statement like with context or async, some calls like that. So it's very easy to use. So anyway, so here are some links, and also the sample app is available on my GitHub. So if you are interested, you can check it out.
And I think we have time for one question through the audience before we're going to go for a break.